I'm your host, Chad Jackson, Chief Analyst and CEO of Lifecycle Insights. Today's episode features Fix the Mask co-founder and inventor Sabrina Paseman. As a part of Siemens' hardware startup program, Sabrina and the Fix the Mask team have been tirelessly working to supply better masks in the fight against COVID-19. Sabrina, nice to meet you.
Nice to meet you.
Your all story is a really interesting one, especially, with everything going on right now. With this startup, can you share a little bit of what you all are doing and kind of the product that you're making with the audience? How'd you come up with this idea for Fix the Mask and the product concept?
Yeah, absolutely. So this all started back at the end of March, and the inspiration for this project really came from my brother-in-law, who is an emergency doctor on the front lines at a local hospital in my area, and his hospital was running short on PPE. It was a really rough situation for his family and also, by extension, my family as well. And we first wanted to find any solution that we could to solve this shortage. So what we started out doing first actually was calling a bunch of hardware stores in the area just to see if they could donate their unused N95 masks to our local hospitals. And after the first day of effort, we actually were able to source a few thousand masks, which was really exciting. And we were hoping that this would be a solution to our problem. We could all go home and feel like we were going to be protected. But what happened was the next day and the day after that, we slowly realized that all of the hardware stores were closing off their supply to the public because it was government mandated. And so we recognized really quickly, and this was back in March, that we needed to find a more scalable solution, that the global shortage is going to be a really big problem, and just trying to source locally was not going to cut it. So I have a product design background, and what I did then was I tried to understand, is there any other way that we can make something that may be close to the equivalence of an N95 mask? And in order to do that, what I did first was I took apart an N95 mask to understand what makes this thing so good. Why is this the golden standard for our protection? And upon tearing one down, I recognized that effectively all it is a sealed filter. So the filtration material that you see in the N95 mask is actually a stack up of 3 different, or spun bond fabric, melt blend fabric, and spun bond fabric, all sandwiched together. And after understanding this, that all it is a sealed filter, I tried to understand, well, is this material available elsewhere? Perhaps in an underutilized setting. And then we could use that instead to sort of bridge the shortage. So I looked around, and it turned out that the different supplies of melt blown fabrics are relatively slim. And the reason why is because a lot of the other processes that use melt blown fabrics are not qualified for filtration. So as you can imagine, the critical factor of an N95 mask is its ability to filter out a certain amount of particles, specifically 95%. So, for example, dryer sheets are not able to do that. But I did find that surgical masks that are rated to the ASTM standard are also held to a very high standard of filtration. And so that sort of clicked for me. I understood that the filtration potentially was comparable between an N95 mask and a high quality surgical mask. And I was wondering why the government wasn't at that time recommending the use of surgical masks. And all of the literature online sort of showed that basically surgical masks are loose fitting. Every single article I found was like, they're loose. And so basically I had a brainstorm and thought, why don't we just seal a surgical mask? If we're able to seal a surgical mask, could we actually just bridge the shortage? What was really exciting about that was I took a look at the manufacturing production of N95 masks versus surgical masks. And it turns out back in March, per day in China, 0.6 million N95 masks are made, but 200 million surgical masks are made. So the ability for us to actually bridge the gap with surgical masks seemed like a really, really good opportunity. So at that point, I basically focused all of my effort in finding a way to seal a surgical mask effectively with as little resources as possible. And the reason why I emphasize the few resources is that in order for us to actually provide a solution for the general public, it needs to be quickly manufacturable, scalable, and cheap, right? Because we can't be investing $40 per mask in order to fix this problem on the global scale. And so what I'd come up with in combination with some other inventors, that I had met from my previous work, we came up with a single piece of rubber that would be put over the nose and mouth and pressed on the outside surface of a surgical mask. And that's where the idea was born. We actually came up with our version 2 design first. And we were so excited at that point that we didn't actually have any rubber sheet to prototype with. But I was so jazzed about this. And this was at like 11 p.m. at night when we came up with the idea. And I was scourging around my house for anything that I could use to possibly prototype this. And I found some rubber bands. I first put the rubber band on my face and I felt it seal. And I was like, oh man, this is going to work. This is a really, really good idea. So that night of invention was probably one of the most exciting that I've experienced in my career so far.
That's great. Mm-hmm. Can you talk a little bit about the process that you went through to kind of validate the actual effectiveness of the design?
What I've learned is that a good mask design needs to meet 3 criteria. The first is its ability to filter well. The second is its ability to fit well. And the third is breathability. So meaning how much resistance there is to inhale and exhale and how much carbon dioxide buildup there is inside of a mask. In order for a mask solution to be effective, it has to meet all 3 of these criteria. And with our solution, we're meeting filtration by utilizing high quality surgical masks. We're improving fit by the addition of our brace, which we're validating. Breathability also is addressed because surgical masks actually are more breathable than N95 masks.
Wow, that's fascinating. So it sounds like you're modifying existing masks. Can you share with us the process of how you fix the mask?
The best part of our solution is that it's so simple. So all we're doing here is sealing a surgical mask. So all we're doing is taking a surgical mask and attaching an elastic outside ring that goes over the nose and mouth and applies a positive pressure. So we have 3 different iterations of our design. The first is our version 1.0, which is our rubber band solution. And that one actually gained a lot of traction in countries like the Philippines and India at the start of the pandemic, which was really rewarding to see. It was being really virally shared, which was a very gratifying experience to know that something so simple could have such a large impact. Our second solution is our version 2, which is the rubber sheet that we'd alluded to earlier. And the benefit of having it be a rubber sheet is that it's a single piece and easy to clean and reusable. And it's a lot more reliable, for example, than a rubber band, which, is a lot thinner. So that's the heart of version 2. And now we're very, very excited to announce we've been using the data from the version 2 feedback and improving on our design. And so we have finally created our next iteration, which we're calling the Essential Brace. And it's made from FDA silicone. It's improved from a comfort and function standpoint. And we will be mass producing it to make it available to everyone.
That's great. This is such a great story. It's awesome. I know a lot of startups, they have a lot of challenges getting going early on. What about you all? What challenges did you face early on with your company, both from a business perspective, but also from product development?
I'll start off with some positives. The positives were that our team at the beginning was so organically able to work together at a distance. And that, I think, was incredible because at the beginning of this pandemic, no one really recognized that it was possible to work together, not in the same office building. And our growth at the start was so fast paced and so, I said the word organic already, but organic because everyone was united in our purpose to just do whatever they could do to help as many people as possible and use whatever skills they had to basically move this project forward. So that start was really, really strong for us. And I think really unified us as a company because we had such a strong mission. Now, the issues that we had, I think, and this is our issue now and probably moving forward as well, is that we basically are battling the pandemic here. We're on the pandemic timeline. So if we have any roadblocks, we're basically trying to move fast enough to still have an impact with the current pandemic. Every day that we delay, more lives are lost. And so the stakes are really high here. But I think given the fact that this product has the potential to help so many people, it's really pushing my co-founder Megan and I to be the best that we can be.
That is so great. So that's kind of like, what challenges did you see early on looking backwards? Let's shift and look forwards now. Going forward, what do you anticipate in terms of challenges that you're going to meet in the future?
Yeah, I think the most challenging part is that obviously no one really knows how long the pandemic is going to be with us. And we're hoping that in an ideal world, no one necessarily even needs our product, right? Everyone would be able to be safe and home and healthy and be able to go out whenever they want. But at this point, because there's still so many unknowns, I think our biggest issue moving forward is trying to navigate that. So again, we're trying to work as fast against our timeline as possible to really push the boundaries of what it takes to bring a product to market. And I think that both my co-founder Megan and I we worked at Apple. We're very aware of the process. It normally takes, 2 to 3 years to bring something really strong to market. And here we're working on the order of months. So we really have to compress everything, like take everything that she and I have learned in our past near decade of experience in the real world and condense it to be literally, we've only been around for 3 months so far and we're already almost launching our first product, which is pretty incredible. So it's been a wild ride so far, and we're working really hard to get it out as fast as possible.
Yeah. Sounds like your experience has really made a very big impact on the success of the product. Can you tell us a little bit more about what do you feel you're achieving with this mission? Making a positive impact on the community. What are you seeing?
This has been, I'd say, the most rewarding product that I've ever worked on. I mean, this product has the potential to impact hundreds of thousands of lives. And what we're doing can actually potentially change the course of the pandemic. And it's crazy to think that, something that it thought up just, at the end of March is nearly ready to go. And we're just at the edge of pressing go and being able to impact a bunch of lives. So it's been so rewarding already. And one of the most exciting things is that even with our version 1 and version 2 products are going to be on our website for free for download indefinitely. And we've been getting so much positive feedback from those, for example, dentists that don't have access to N95 masks, but do have access to surgical masks. And we get these emails that groups of dentists have, downloaded our design and made a giant party out of cutting out braces for themselves and their family and friends, which is amazing, right? It's just, this product it's so cool. And the cool thing is that it's so simple that everyone can get on board immediately. Even still, it's able to impact so many lives.
That's great. That's so amazing. I'm interested, these types of efforts involve people, process, and technologies to kind of make them happen. From a technology perspective, I know you guys have been leveraging the Siemens solutions to kind of do the design work and the development work. Can you tell us a little bit more about that? What part did they play?
I will say that our main barrier to going from our version 2 to our version 3 was the software that we had available. In fact, during our version 2 development, we recognized the need for basically higher surfacing capabilities in our CAD software, et cetera. Luckily, I had found out about the amazing startup packages that Siemens is offering just at the right time when we were really ready to start doing development. And that price point really helped us actually move forward with our product. So I would say at Siemens, the NX software has been absolutely instrumental in getting us from our version 2.0 design to our essential brace. I went through literally dozens of different designs in the CAD software to figure out how to fit the majority of faces with the minimal amount of shapes of the brace. So that was definitely not a trivial task. And I think that specifically NX excels in surfacing. So what I ended up doing was I took a look at the CDC offered downloads of 3D printed faces. And I took in that software and I used those to develop a nose cushion geometry that would fit the majority of faces out there. And what's really cool about it is that the CDC's website averaged about 5,000 different faces into 5 different heads. So it was really great to be able to import that, manipulate those really quickly with the NX software, and be able to iterate on the brace design as quickly as we did. I'd say that if we weren't using the NX software, it would have taken probably months for me to figure out how to do that otherwise. So we're so grateful for that. And NX is absolutely my choice of software when doing anything involving interesting surfaces, because all of the synchronous modeling and the surfacing capabilities are pretty much unmatched in NX compared to the other products that I've worked with.
Yeah, that's a great application of the technology, especially when you're able to explore more options. That can make a huge difference. So let's project a little bit more into the future. Let's look 5 years out. What are you and Fix the Mask doing? What's it look like?
Yeah, so our mission at Fix the Mask is to provide safe masks for everyone quickly, and we're not going to rest until everyone has access to proper protection. We recognize that there are large populations of people that can't afford the $7 price point of the N95 right now. But the pandemic does not discriminate between income level. It's going to infect basically whoever it infects, right? And so our mission as a company is to be able to bridge that gap. Basically, we're hoping that obviously the pandemic does not last 5 years, but we believe that this technology is going to be really impactful, particularly for the short term with specifically coronavirus. But if there's ever any other aerosolized virus pandemics that come up in the future, we want to be ready for that. And so we're working really hard to make sure we have a really solid product that's going to help as many people as possible, as quickly as possible.
So making sure that there's a good seal on the mask, how exactly did you simulate that or assess that with your 3D models within NX?
So within NX, it's a little bit challenging. I'm going to rephrase the question into how we define fit for our solution. The way that it's done actually in hospitals is there are two different methods. One of them is a qualitative fit test, and the other one is a quantitative fit test. So for the qualitative fit test, what that looks like is they take the physicians that are about to go out onto the floor, and first they shove their heads inside of bags and they spray a spray that either smells sweet or bitter. And if they can smell the spray inside of obviously they're wearing a mask here. So if they can smell it through their mask, they've failed. And if they don't, then they pass. This test method is pretty archaic and a little invasive. And so, not our preferred method, but it is one that is relatively cheap and a lot of hospitals use. But the other method actually is something called a quantitative fit test issued by something called a Protocount Pro, which is a machine offered by TSI. And actually the OSHA standard uses the quantitative fit test as part of their qualification. So what that does, it's a system that is able to measure particle count both inside of a mask compared to the ambient outside of the mask. And it does a ratio, in fact, of the outside to inside, and it outputs something called a fit factor. And so if you have a situation where the inside of the mask is 100 times cleaner than the outside of the mask, then it's rated as N95 fit has passed. What we did with our solution was we used the quantitative fit method, and we tested our rubber band design, our version 2 design, and our essential brace design against that system. And what we found was actually that we passed with flying colors, particularly in the essential brace. And what's really cool is that the OSHA test actually takes the person through a couple different use cases. So at first, they just have the person doing normal breathing, then deep breathing, then turning their head side to side, up and down, and then talking. And then finally, normal breathing again. And the talking one is one that actually fails on a lot of doctors, even with N95 masks. And the reason is because N95 masks are rigid. And so you can imagine that if you move your jaw with something that's rigid on your face, it can break the seal. And so what is common is that the OSHA test actually allows for one of the failures in that test method. And you can still actually go out into the field because they do like an average of those 6 to 7 tests. But with our solution, we actually pass with talking, which is really, really cool. So our fit factor on our sample size so far is our lowest talking score was 170, meaning that even while talking, the inside of the mask was 170 times cleaner than the outside of the mask. So I think because of our elastic brace design, it actually is a better design solution than a rigid mask.
Yeah, because it's more flexible. Yeah, okay. That's great. So something else I'm interested in, you talked about working with other people remotely. And I imagine there's experts all over the globe, maybe all over the country that wanted to participate in this. How did you collaborate with them on designs? How did you share, what you're working on and kind of give them insight into what you think and your ideas and vice versa? How'd that work?
It's been an amazing process. So the first thing was, I guess, recruiting people that had a similar mindset. And I think especially at the end of March, there were so many forums that had like thousands of people just integrated. And it was hard to figure out which problems people wanted to contribute to. And it was just a giant mess. And the way that we did it instead was I basically pinged my LinkedIn network and I basically put out a proposal of our idea in a visual format. And that actually recruited a lot of really like-minded people quickly, because if they understood the image, they basically emailed me and said, I want to do this aspect of this part of the project. And I would say, totally go for it. Take your time, like, give me back any feedback. And we basically worked through that method. So anytime anyone had an idea out of something that we were working on, we basically just let them run with it. And because everyone in our team had different skill sets, we actually didn't have very much overlap at all. Everyone was able to contribute in what they were strongest in. And that really pulled our project to the forefront, I think, within the first month compared to other projects that were going on. So that was a really powerful experience and showed to me that it doesn't necessarily matter the proximity of your team members. What matters is if you're aligned in the mission and you're so committed to achieving that goal, it doesn't really matter, how far away people are. People are going to contribute exactly what they can because they're motivated to.
I think that's really aligned with a lot of startups. I think there's a lot of companies are discovering new ways to work with people from all over the place. I'm really glad you're able to make that work with your application, being so worthy of such an effort. How did you all correspond? And how frequently did you correspond? Did everybody go away for a week and then get back together and say, okay, this is what I've done over the last week? Or was it more frequent? Or what did that look like?
It was definitely daily, if not hourly messaging.
Wow, really? Okay.
Yeah, everyone was so excited, particularly at the beginning, to contribute. And so anytime we had a new finding, we would all really excitedly share it with each other. And I think there's just so much energy at the start to make such a big difference that no one even minded. I mean, we would be literally call each other at all hours of the day and well into 11 p.m., midnight. And we even had people in different time zones, and that was totally fine with us too. So I think that the energy of the project really just carried us through.
And what about, obviously you leveraged Siemens digital technologies to do a lot. You talked a little bit about that. What other support did they provide? I mean, it's not just about installing software. How else did they support your efforts?
Yeah, I was so impressed by the ability to get support. I had a couple of surfacing issues actually on one of the parts that I was trying to work on. And I reached out to one of the representatives and I was able to get an answer really, really quickly. I think it was underneath 24 hours from when I had the problem to when it was resolved. So not only that, it's really cool to have such a strong product be backed by such strong customer service too.
It's great. That's excellent.
Great. Thank you guys so much for your time.